Hello everyone, my name is Andres Menjivar Jr. and I'm a senior here at UNC Chapel Hill. The project that I'll be going over today is panoramic stitching. So, a quick overview of panoramic stitching and the process I went about in my attempt to execute it. So, we begin by taking a series of images, these being my own, with the same center of origin. The goal is to have our middle image be representative of a plane that we want our surrounding images to be on. So we do this by commuting the homography between the left and middle image and the right and middle image. So we begin by attaining 4 points that each pair of images have in common. From here, we compute a homography matrix between the pairs. Now, from lecture 17, slide 30 of our class, we are given that homography is a 3 by 3 matrix with 8 unknown variables, and our last being I equals 1. We are also given this system of equations on the left side. Using that as our starting point, we move everything to one side to end up producing an AH equals 0 system. Now, whenever you solve for this and then rewrite it in matrix form, you end up producing the first two lines of the matrix that you see on the right. Now, in order to have every x, y, and x prime, y prime pair, what we have to do is just duplicate these two lines 3 more times, which will initially give us a 8 by 9 matrix. Now, the reason we have a 9 by 9 is because we also want to ensure the fact that our I is equal to 1. So we do this by adding a row of all of zeros at the very end with the 1 right at the end, as well as a 1 being appended to the end of the column of our 0 matrix on the right. And this is just as confirmation to ensure that our I equals 1 whenever this is solved using least squares in MATLAB. So as a result, we end up producing a 9 by 1 matrix being representative of our homography. So what I end up doing is that I rewrite it into a 3 by 3 and pass that as an argument to projective 2D to compute a T-form needed to warp the image. And here's the result of that. Now, if you notice, these results are a little finicky. These are probably one of the better ones I had, but one of the early issues that I had was that it was very dependent on the points that I ended up selecting on each of the images. Now, from here, what we end up doing is that we first begin by using the middle image as a background. Now, to ensure we don't have any issues with the cut and paste method, we end up adding just a ton of padding, which I believe, if I'm not mistaken, was something between the lines of like a fourth to a half of the width and height of this image. Now, once we add the padding, we end up selecting the portion of the left image that is not within this middle one, and we end up pasting it as close as we can to get the lines to match. And what we do is that we then use this middle one as the new background for the cut and paste method, and then we do the same thing with the rightmost image. We select portions that appear on the right only and not on this that's already present, and we end up pasting that, giving us the result on the right. Now, some issues that I faced very early was deciding the points for warping, because as I mentioned, these points resulted in very skewed or very close warping methods that kind of matched with the lines. Now, another issue was the cut and paste. I realized that didn't seem to be a very clean method of combining the images. Probably a better one would have been pyramid blending. And the last one obviously would be time. Obviously, if you notice, I only showed one set of images because that was all I was able to do successfully. If I had more time, I probably would have been able to do the set of 5 images, but I also would have been able to have much better results regarding the warping. And that's all for today. Thank you all very much.